this specific event is geared towards talking about how obviously a game like Snake can be developed using Lua. It's going to be two-faceted. It's going to be like an introduction to the technology, and it's going to also talk. We're going to talk about implementation specifics. So that's going to be two things. A bit about myself. My name is Ahmed Maawy, and I've been in software engineering for close to 15 years, including also working with organizations like Al Jazeera, AJ Plus, and BRCK, and Ushahidi, and EveryLayer Broadband. I've been involved in projects like Express Wi-Fi and all that. And right now, I'm the Vice President of Engineering for an organization known as Streamlytics, which is focusing on getting folks paid for their streaming data, as well as being able to provide analytics on the data that we're collecting around streaming platforms from various users. But at the same time, we allow users to get paid for their data. When I was at Al Jazeera and AJ Plus, I did digital backends, I did mobile apps. In fact, even the current Al Jazeera Android app that is on the Play Store is actually was actually mostly my work. The Al Jazeera English app. And so I've been in various different fields, but I have also a passion for game development and game technologies, which is what we're going to talk about today. So for us to sort of understand a bit of like what we're going to be talking about, and obviously this is going to be a bit of an interactive session. So what I would love is, for instance, if there are any questions and all that, I could be able to answer them. But we're going to talk a bit about the technologies that we're going to cover. So, for instance, behind the scenes, what is Lua? So Lua is a powerful, efficient, lightweight, embeddable scripting language. And by powerful, it means that it can do quite a lot of things. It's quite sophisticated. It's very much capable by being able to work with C, C++ very closely at the base. It's efficient and lightweight. It's got a very small footprint, so it can be able to work with speed also. You know, so and it's quite lightweight, it's quite small, it's quite, and it's easily embeddable. Its footprint is quite small, that's what it means. It supports procedural programming, it supports object-oriented programming, it supports functional programming, it's sort of also enables data-driven programming and data description. These attributes actually make it very suitable for games, especially the fact that it's powerful, it's efficient, it's lightweight, and it's easily embeddable. So what game engines do, or game developers do, is they sort of embed it into their game programming quite easily. So Lua has been behind a lot of very successful titles. So for instance, games like Move or Die, Zip Zap, Family Island, Candy Crush, and all the games at King that are like Candy Crush are actually developed on Lua. So there's a lot more than this, to be honest. There's a lot of games that Lua has been able to develop in the past. When we talk about game development, we're also going to talk about like what are the options that you have when you do game development on Lua. And there's two ways you can go about this. You can either go low level, where you can explore bindings for Lua to low level libraries like SDL, OpenGL, etc., and tie that to either C, C++, or the already bindings that exist for this to happen. So like there are Lua libraries that already have bindings with SDL and OpenGL. And what SDL is it's sort of an abstraction for things like graphics, things like user inputs, things like what do you call it, sound processing and all that, things like threading, things like, so SGL is like a collection of libraries that allow you to easily be able to work with game mechanics on the low level side of it, but then it creates a bit of an abstraction. And OpenGL is obviously like, it is a graphics technology. It is a graphics and rendition technology. So like you could either go very low level and work with these technologies directly, or the second option you can use with Lua is to work with something known as a game engine. So game engines, they are software layers on top of. They're software layers on top of the very low level implementation, but what they're geared towards is creating a conducive library model and ecosystem model that allows you to develop games. So good examples of game engines are, for instance, the Default engine, the Love2D engine, and Solar 2D. The route that we're going to take for this specific presentation is going to be making use of an established game engine, in fact. So like, we're going to talk about that very soon. But the other important thing to know before you sort of dive into doing a game is what does each game have? So a game has an initializer, it has a game loop, or something known as an update loop. It does draw calls, which are also the rendition bit of a game. It has sound and audio elements, game input handling, and may include physics. Okay, sure. So now we're going to talk about talking about the technology specifics in the previous slides. So now we're going to talk about implementation specifics. So what we're going to do is we're going to use an engine known as Love2D. If you search for Love2D over Google, you're going to get the game engine itself. It's not particularly a game engine. It's more of a game framework, but it is termed as a game engine. We shall assess an already simple open source Snake game done on Love2D in detail. So it's not that I'm going to do my own game. It's already an open source game that is available, and I could actually like provide the link for the source code later on. I can provide that. But then what we're also going to talk about just now is you're going to see that Love2D has a mechanism that it uses internally to implement some of these things that we have talked about in the previous slide, which is the initializer, the game loop, the renditions, sound and audio. So you're going to see these elements in play by being able to see how Love2D implements those two things, a couple of those things all together. The architecture of the game itself is that it implements an array known as a grid, and the grid has cells. So each of these cells are occupied either by free spots, or are occupied by fruits and obstacles, or on the board itself. The other important element you're going to see is there's going to be a bit of collision detection within the game implementation itself. So with that said, if there's any questions before we start getting into, I'm going to open up the code editor, so you're going to see how the code is, and I'm going to show you how it runs, and then we're going to look at the code in a bit more detail. Are there any questions up until now, maybe? So.
Yeah. I've seen some in the chat.
Questions? Okay.
Okay, let me just check the chat. So.
Maybe Harrison, you can ask the questions.
Okay, let me read them out. So the first question is, the person asks, do I need to combine Lua with other programming languages? And slightly coupled with that might be, can I use Lua in Unity?
Okay, so those are two different questions. Okay, so I can tackle the first one first. Do you need to use Lua with any other programming language? Now it depends on the, it depends on your, what can I say? It depends on your scenario. There are a good number of situations when you will just use Lua, right? And especially if you're just doing quick games, it's possible you might just do Lua without combining Lua with any other languages, you know. So for instance, if you're using, for instance, a default engine, the default engine does come with a number of modules in the asset. It's called an asset store. I'm not sure it's called an asset store, but they have a place where you could download assets. So like, for instance, you need plugins to do things like AdMob. You need plugins to do different things. They already have that. So you don't need to go develop your own modules. Now, most times these modules are actually, what can I say? These modules are actually down below coded with C++. And there's like a mechanic that they use, even if, for instance, they're using it on Android, they use something like a native interface, which is a C++ binding to the Java code that runs the game instance itself. You see, so there might come a point when you might need to bind it to especially C++, depending on how complex your game is, or depending on what engine you're using. So for instance, if you're going to use Love2D, chances that you have you're going to have a library available for something that you're going to do. Chances are slimmer compared to when you're using an engine like default, you know. So you might have to develop C++ bindings with Lua that will, if it's on Android, bind to your Java program, that will bind to, on iOS, it will bind to your Xcode, you know, and all that. So like, it depends on the scenario. But for most use cases, and if you're using an established game engine that has a lot of support, chances for you to be doing that are very slim. You might just end up just using Lua from start to end, you know. The second question is, can you use Lua on Unity? So from what I know in terms of what Unity does, Unity is very, it's very locked up to using C#, all right? Unless you get very smart with mixing Lua and C# at the very low level implementation, then that's a different thing. And I don't see a use case for that. But I don't think it's designed to work that way. So I'm not sure that is possible. So yeah. Any other questions?
So there is someone asking if you could share the slides after the chat, and if that the session will be going to be hardware intensive. I guess maybe the code is referring to the code.
So hardware intensive in terms of what way exactly? I'm trying to understand. Hardware intensive as do you mean like
maybe Brighton can...
Hello?
I'm saying Brighton, the one who wrote the question, can expand on that as we continue.
Yeah.
And then we can maybe better answer the question.
I might interpret it in one of two ways. It's either it means hardware intensive in terms of maybe it consumes a lot of resources GPU wise. I mean, it's really just dependent on the context of what you're trying to do. Hardware intensive can also mean that, is it, does it, when you work with it, like, do you need to have like a console, or do you need to have like a mobile device? It depends, end of the day, on the feature sets of the game engine. You know, if you go very low level, then you have to do those yourself. You know, so I don't know if that is what answers the question. You know, so
I tend to think that the same approach, so we can proceed.
Yeah, so I can show you maybe a bit like how the game runs and how the code is structured, and then like we could deep dive a bit into the code. Okay, so like for instance, this is like the game that's coded on Love2D, but then when you want to run it, you sort of give it, once you install Love on your machine, it comes as a set of libraries that you could install and all that, and you could use the CLI to run the game itself. As you see, like it then shows this app. You could select a mode. You could start playing around with the snake itself, you know. So like there's collision detection. It can collide into itself. It can detect if it's colliding into itself and all that. So like the mechanics, you see, like I collided to myself, I was able, and the game sort of like finished up, you know. So it's comprising of 3 main files. There's draw, Init.Lua, main.Lua, which I'm going to explain in a bit more detail, you know. So let me just do that. So I actually took notes that I'm going to present, right? I'll definitely find a way to this slideshow maybe into a PDF and share it with you guys. Maybe you can share it with the rest of the guys later, if that's what's required, you know. So and then obviously I can provide a link to this gist, which is it explains how the game is sort of architected itself. So, you know, when we talked a bit earlier, we talked about elements of the game, including game initialization, game update loops, you know, and draw logic, you know. So I'm going to explain this a bit more, you see. So what happens is that the game initializer sort of initializes the state of the game and sort of creates the environment on that and the state for the game to begin. What update does is there's something known as a frame rate in every game. So let's say the most ideal frame rate for most games is 60 frames per second. And this is mostly handled, the rendition for this game is mostly handled within the draw, and the draw logic is what deals with the GPU mostly. But the update works on each frame. So like if you have 60 frames per second, the update logic is called 50 times. And mostly the draw is called whenever there's need to change any elements. So for 60 times a second, this update function is sort of called. And what's important is that since that happens, what you need to do is you need to make sure that your update function is very optimal. It's not, the performance for this has to be flawless. So you would not want to overwhelm game logic in update that you can do in other places a bit more smarter. So if you want to be able to, if there's things you can handle outside the update function without having them being executed in update, it's better to put them outside the update function itself. So what the update function mostly does is it deals with updating the game state so that it can also be able to be renditioned when there's a need. So we could also say draw could be called 60 times in a second because it responds to updates that are being done after the update logic is run. You see, so that's sort of one of the things that you should do. But anyway, let's start talking about the initialization itself. So the game loader has a function known as love.load, which is exactly this one here, which is in main.lua. And what love.load does is it initializes the state of the game. So in this case, it sets a title for the window which is renditioning the game. And in this case, the window wasn't maximized. So you could see, for instance, that it was there's no need to maximize the window. So it can set the title for the window and as snake, right, at the very top. And then it initializes the screen variable, which is the screen variable is actually what is used to track the active state of the game. I'm going to talk about this a bit more. So there's three major states for the game. There's a welcome state, there's a playing state, and there's a lost state, all right? It initializes it to welcome, and what welcome does is welcome displays the welcome menu, the first menu you saw where you select the mode of the game, which is Zen mode, all that stuff, right? It then initializes, it then like provides shortcuts to things like the Love the Graphics, which is the graphics subsystem for Love 2D, which allows you to do things like draw circles, draw triangles, draw rectangles. All that is in Love.graphics. Now, there are ways you can be able to work with images, but for this one, you don't need to do that. But that's a separate discussion. When you get to using sprites and all that, that comes later. Love.keyboard deals with keyboard input. You're going to see that in actual sense, in actually the update function, we're tracking what key was pressed for us to be able to set the game state properly. Love physics is just to create the other element in games is a physics element, but it's not very heavily used in this example, but it can be used in other areas in other sort of games and complicated physics. So for instance, you want to create a real situation where things bounce off each other. There's gravity, there's when things collide, how they respond, you know, and how they proper like physics setups. But that is beyond the scope of this discussion itself. We're just going to see a very basic implementation of it at the moment. So you see that the thing that is done during the initialization is it creates a background color for the game itself using the Love.graphics subsystem, which is sets the window background color for the game itself, you know, and also sets the dimensions of the window that we just saw, you see. So these are the important bits of the game initialization loop, all right? And then the update loop now is the major one that deals with things like the state transition between the various states, and also uses variables to keep track of the various other things that happened, all right? So you're going to see that one of the things it does when it is in the playing state is it tracks to see if the left or right or down or up keys have been pressed or the escape key has been pressed, all right? When you press escape key, it automatically goes to the lost state, which is a game over state, all right? So one of the things that happens in the update loop also is that it sort of also gives you a delta of the time difference in between the frame, the different frames. So if, for instance, you have 60 frames per second, each delta is going to be 1/60th of a second. So you can use that to calculate time differences between the various different, various different frames that come. So this DT here, when you see the love.update function of the DT is a delta, and it's actually, what can I call it? It's actually the same. It's directly proportional to your frame rate. So if your frame rate is 30 frames, it becomes 1/30, becomes 1/60. So it depends. So the delta, you can use it for time intensive calculations. All right. And then you're going to see that one of the things that you're going to see within this is the fact that it also tries to detect if there's been like collisions with for instance the different elements, and informs the game if the game state if there's been collisions and all that. And also when it's playing, it updates the state of the game. So for instance, after every 1 second, the snake is supposed to be moving to the next cell, which is what happened here. You see, so like you start moving the snake, and then you also sort of track for collisions. I'm going to show you what happens collisions a bit later. You track the collisions, then you sort of then update the game state after each and every second. So that's what happens. So before we go to the draw logic, one of the things that is very important in games is collision detection. So there's actually a function known as collision XY, and its work is to be able to check that a specific collision happened into it and maybe itself or an obstacle. All right. So the Zen mode doesn't have an obstacles, but the other modes actually have an obstacle. So we're going to look at the game again later. We're going to see that. So the body part collisions is obstacle collision, and what happens is that if there's a collision that happened and it's able to check against the matrix that was set up, which is an array, a multidimensional array, it tries to see if the snake has hit an obstacle. And it actually returns true if it has, between itself or with an obstacle, so when that happens, then it's supposed to issue a game over. So you're going to see that in the update logic, what happens is that if the collision was done, then it transitions the game state to lost, which is a game over screen. You see that? And if, for instance, the major game state was welcome, then it tries to sort of provide the menu. It displays the menu, which is done in the draw logic anyway. It displays a menu, and then depending on which key was pressed, so you saw that the menu had the numeric options. It initializes a game. So this game init is actually a function that is outside of the main.lua file, but its major responsibility is to be able to initialize the array that I was talking about earlier and give it coordinates for the snake, and give it coordinates for obstacles, and give it coordinates for the various, for instance, like there's fruits, there's all that, like it does that, so it initializes a game state. You see that? Now, one of the most important parts is of any game is a rendition, which is a draw logic. So the update, what you do in update is you just update the game state. It's not advisable to do draw calls in the update. The draw calls are actually done inside the draw, so the love the draw. So in this case, you're going to see that is right here. I mean, is it here or is it here? Sorry. Yeah, so you're going to see that the love.draw function is inside a draw.lua file. And what it does, its major responsibility is to be able to use a graphic subsystem to draw rectangles, to draw color, to fill colors, to draw circles and all that. And these like circles and rectangles are actually like they're to do with obstacles, they're to do with the fruit, they're to do with the player, the player position itself. You see that? So there's a very thin line between the update and the draw function, but the division is that you put your rendition inside draw, you put your state management inside update. You see that? So like this one now is responsible for actually drawing the various elements, like the snake's position, the snake's size, where the obstacles are placed, where the fruit is placed. This is done in the draw call, all right? And the collision detection is done inside the update call because it's related to variables, it's not related to what you see. So in actual sense, when you're checking for collisions are related to positions of objects which are actually variables. They're not related to what is drawn on the screen. The rendition is something that the user is able to see, but the processing for collisions happens outside the draw calls. So some of the other extra functionalities that you're going to see is like, there's two important functions known as the new fruit and the generate obstacles, which are called during the game initialization logic. And what this does is it sort of generates the obstacles and places the fruit into the matrix that was just initialized inside the game init function, you see. So if we were to look at this again, with all this sort of in consideration, if we select the arcade mode, you're going to see now the arcade mode actually has obstacles. So the obstacles are rectangular, as you've seen that, like they have, and the Zen mode doesn't have obstacles, just has the food. It has the snake itself. You see, so depending on the mode that you sort of select initially, then either creates the obstacles, it doesn't create the obstacles. So you see, like the collision detection happens. You see the sort of what you call it? The title of the window was set as we had earlier talked about. This is a game over screen. This is a state that was actually lost. And when you sort of press enter, it goes into the welcome screen. The welcome screen now had the text inputs. And when we relate it to the code, you're going to see that what happens is that as you see here, the menu is renditioned within the draw call itself, as you've seen here. Like anything to do with text, anything to do with the circles that were renditioned, the squares that were renditioned, and all that is done inside the draw call. As you can see, it's not done within the update function itself. But what update does is it tracks. It makes use of the various game states and the variables to actually update the game state itself and not draw the game logic itself. But then the other functions that we were supposed to talk about right now, which are the, what can I call them? The new fruit and the generate obstacles. These are used when you're doing the initialization logic itself for the scene itself. So these ones are called as functions to sort of, what do you call it? To automate the process of, or to modularize the process of sort of generating these obstacles and placing them in the matrix, and also putting the fruit into the matrix. I don't know if there's like any questions up until then.
I haven't seen any in the chat, but I'm requesting anyone who has a question to post it in the chat.
Yeah, I mean, we could talk about various different things, not just the game itself. But if you're curious about any specific topic, also when it comes to game technology, game development, and all that, like feel free to also chat it or ask that question if there's anything, or you can suggest something we can talk about, especially the moderators. So the reason why I initially thought it would take quite a long time is because I wanted it to be a bit more interactive. I wanted to sort of have guys ask questions and all that in the various different sections that we were going to talk about. You know, but it seems to have flowed to the very end. You know, so I don't know what is there any other question?
I have a question myself. I'm not more into game development, but quite from what you've taken us through, I just have a question about how can I maybe, like, since I've seen you running the game via the terminal, do I need to like write code for an app so that I integrate the game to run on the application, and then now to publish the game on Play Store or whatever other platform?
Yeah, so you see, anyway, I think maybe I should show you some things, yeah? So game distribution is part of the game development process. So for instance, when you look at Love 2D, but for instance, game engines like Default and all that sort of really automate the process of exporting to Android, exporting to iOS and all that.
Yeah.
But there's now where, for instance, you would work with the native libraries within Android and all that you can't replicate on the screen. So for instance, what you saw me demonstrating on the screen can work with functionalities that are that are natively available on the operating system itself. So in my case, it is a Linux, and it can work on Windows. It can work anywhere else, right? So if I export this game, for Android, it's going to work. But there's a process you have to follow for instance, with Love 2D, whereby you can download the APK for Love 2D, and then you can, when you want to do something like game distribution, you can then make use of, let me show you, something known as an APK tool. And what an APK tool does is it allows you to sort of integrate whatever you've compiled into a .love file. So when you compile your entire game under Love 2D, you can compile it to a .love file. And then you could put it in a specific location of the APK, and you could distribute it as a game on its own. So for instance, with Android, I'm going to show you that thing known as the APK tool. I don't know where it is. So you could use APK tool, right? And what you do with APK tool is you sort of modify the APK, which I just showed you could download, and then you could place your game, your compiled game inside the APK, and you could work to distribute your game. So there are scenarios where you would need to work with functionalities that are natively available within a specific. Like for instance, you could want to work with some native functionality on the mobile device and test on the mobile device. So for instance, with game engines like Default and all that, it has a way to automatically deploy it and test it on your device if it's connected to your computer. But if you're going to, so for instance, use Love 2D, it's going to be a bit of a manual process. Now, there's ways there's for instance, if you want to, for instance, export it into consoles. I don't have any experience on that myself, but if you want to export it to consoles, it's a bit of a tougher process because you have to work with SDKs, manufacturers, and that, and create ports for your game. Some game engines are not easily portable into other other environments. Basically, if it works, the thing is, if you distribute it on your mobile, you just need to find a way to handle the input differently. So, for instance, the mobile device have a keyboard. So, how are you able to maybe replicate it? That you can then make use of using keyboard. So you have to think about those questions when you want to create a game that can on desktop and a game can work on the mobile device. But what you saw was mostly just working on the desktop environment.
Okay, so great. Thanks so much.
What other questions are there?
There are several other questions in the chat. Maybe I can read them out. So there's someone asking if they can use Lua for design or they have to learn 3D.
Sorry, Lua for design? I'm not getting that.
Yes. So maybe the person comes from... Sorry.
So you're talking about the elements in the game, the design elements, isn't it?
Yes.
Yeah, so 3D is a different topic altogether. You see. Yeah, so 3D is a separate topic altogether. Now, with Love 2D, it's mostly geared towards 2D, but there are people who have created 3D modules that you can use within Love2D. But like for a game engine like Default, it does have support for 3D models. So for instance, if you're going to export your assets from, it's a good idea to use software like Blender for your 3D designs. And then what you do is you create stuff like meshes or stuff like 3D models, and then you sort of export those 3D models into your game, right? And then within the game itself, you can be able to work with those 3D models and all that. So it's a good idea. Lua itself doesn't handle you being able to design those things, but it does. The game engines do have a provision for you to be able to import models written in 3D software into your game and make use of them.
So thanks for clarifying that, Ahmed. And that was Virginia asking about using what one can use for designing the graphics. So if I got you right, maybe to reiterate, is Lua is some sort of like, so to speak, for the purposes of this conversation. So Lua is like a back end for the game for scripting the commands
in a way, yes,
instructions in a way, yeah, for the purpose of this conversation. And then you'd be having now graphic tools like Blender or Unity probably, yeah, to now create the graphics or the front end in quotes for game development.
Yeah. So I don't think Unity does come in as a design tool. I might be wrong, but I mean the popular ones are Blender, Maya. Like they are like 3D design software systems that you could then use to generate that. When you're talking about backend, so in gaming, backend is a couple of things, yeah.
Yeah.
So Lua, we call it game logic. All right. There's game logic and then there's backend. So for instance, when you create a game that has a backend that, for instance, is used to track the scores of users, is used to save the game state into the cloud, is used to do multiplayer games, then that becomes a backend, you see, for your game. What you put up on a server then becomes a backend, but then what Lua becomes is your game logic. When you do, so for instance, when you do an Android app, you have your logic, you have your layout files. So your logic is a Java code. Sorry, the logic is a Java code, and then the layout files become your assets, all that stuff. Yeah.
Okay, that clarifies it, I hope.
Yeah, is there any other question that I might not have thought about, I not have seen maybe, or just see if everything was answered? Okay, so do you prefer Lua? Yeah. I think there's this question. Do you prefer Lua over Unity? If so, why? Is Lua programming language on its own? Also a very informative session. Okay. So, you know, there's a group of people though that are quite religious about the platforms they use to develop their games. And the school of thought that I come from is, my school of thought is that you use a tool that, first of all, you love, or second of all, is the right tool for the job. So for instance, myself, I'm not a heavy Unity user because I tend to prefer to use very simple tools because I'm mostly just a 2D game developer. I just do games for hobby. I don't do anything serious. But what I actually do more than develop games is I sort of trick around with low-level code and game engines just for the fun of it, you know. So like modifying game engines that are open source. So I do a lot more of that than actually like working with the games. But what I can say is that it depends on your use case. It depends what you love to use, and what you can just use to get the job done. You know, like it depends. So for instance, Unity is very good if you're talking about proprietary support, ecosystem of tools and components, assets, you know. But when it comes to things like it being open source or open source, you're not going to be able to, for instance, get away with the fact that you could design a game without paying royalties once you hit a specific threshold for a profit, you know. So like with Love2D and Default and all that, like, you own the game, you own the profits, you own everything. It's up to you. And all of them are actually like open source engines. Even like Solid2D is also an open source engine. It came out of something known as Corona Labs. Corona Labs is actually, I know that might not be an appropriate thing to say right now, but actually the technology was called Corona Game Engine. So it's older than this whole thing. It's been there for years, but anyway, so yeah.
Thanks for bringing up the topic on game engines. Maybe you could give an overview on, let's say, a game engine. Of course, you clarified that or mentioned that preference of tools is based on a use case, but also there are IDEs. There's an IDE for Lua. So what would you recommend as the IDE to use for Lua? Because I'd assume most of the attendees are new into game development, so to make the journey easier.
Okay, So, so for instance, it depends on the engine that you go for. So, for instance, one of the engines that I guess that is great on Lua is called Default. Yeah? When you download Default, it comes with everything. It comes with its editors, it comes with IDE. It's a fully blown IDE. When you use Default, you don't have to install anything else, you know. And the history of Default engine is it's an engine that came out of King, and King used it to develop things like Candy Crush, all that. But they have a decent amount of games in the market out there from other manufacturers, and it's known to export to all these platforms straight from the IDE.
Is it open source?
Now, it's open source fully. In fact, it open sourced like 3 months ago, fully open source. You see, so like you see, like as you can see here, the source code is available. You see, so like it's fully open source. You own the royalties for everything you do. The plugin ecosystem for that is part of the asset portal is quite rich compared to very many other Lua-based game engines. So they have a lot of plugins to do so many things like multiplayer, all that. They have quite a decent amount of things on offering. It's as a disclaimer, it's not as straight as easy as Unity to program for instance. It's also quite, it has a learning curve. It can be a bit more difficult, but once you get the hang of it, it's quite enjoyable to use. So for instance, if you're going to use something like, for instance, Love2D, or you're going to use Solar2D, these engines don't come with IDEs. They come as SDKs mostly. And what you have to do is you have to use an editor like Visual Studio Code and all that. With Solar2D, it's notorious for having tools on Mac and Windows only. So if you're on Linux, you're not in good company with it. With Love, it doesn't care. Like its binaries work anywhere. It's true, they work on Windows, they work on Linux, they work on Mac. And it has ways for you to export to iOS, Android, Mac, Windows, and Linux. You know, there's ways you can deal with that, especially if you look at the distribution. With obviously with Default, it comes with all the features inside. Like the tool set is very comprehensive within its IDE itself. You can also like export straight from the IDE to the various platforms that you can export to, but not switch. So the thing with Switch is that you see with these console manufacturers, you have to get a license from them. You have to get approval. You see, you have to get you'll have to sign an NDA with them, and they will give you access to the SDKs after you do that. So they support Switch, but on request, and after you've fulfilled all the requirements for you to be able to export to Switch, they will expose the Switch ecosystem to you, so this doesn't come out of the box straight off. So, but like these other platforms, you could easily export to these ones without problems. So I don't know if that helps.
It does. Thanks for the clarification. And I think we have like less than like 6 minutes to the top of the hour to close up the session. So I'll hand over to Charlene to close the session and raise some questions that have been asked in the chat box. So if Charlene, you can hear me, you could proceed.
I think Harrison can take over for the questions.
Yeah, so I see there's two major questions here. Can Lua be used for creating instant games? Yes, it can, especially with default. It has tools to do that very easily, but with the other engines, you're going to have a bit of a problem unless you hack around them. There's ways you can do instant games, but default has that natively supported very easily. So out of all these engines, default is quite feature-rich that I've just mentioned, all right? Any tips and tricks or advice for beginners? What hardware specs are needed to build games and on a machine? Do I need GPUs? So it also depends on the game engine you're going for and what are the sort of things that you want to develop. But I'd recommend a machine that is at least, if you're on a Linux, you could do with 8 gigabytes of RAM, so Lua is not the good thing about Lua is not very intensive on memory, but it also depends on the tools that you're going to use and the sort of game that you want to develop. Is it intensive of memory? Is it huge? Is it all that? So it depends, end of the day. With these other smaller engines, Love2D and all that, like it's not quite demanding, to be honest. It's quite okay, like you could easily do stuff on an 8 GB RAM machine, It's always best to have a machine that's strong on the graphics card. It has like an NVIDIA graphics card and all that if you're going to do a lot of intensive GPU stuff. But if your machine is capable for simple games, that's okay also. If you want to do simple games, you don't want to do complicated ones. What can I say? Like, it depends. But if you're going to use an engine like Unity, you really need to have good RAM on your machine and good GPU. There's no way around that. So are there gaming companies in Kenya? Yes, there are. Not that they're prominent, but some of them, there's actually a good use case of a game company that is called Internet of Elephants. That is, I could say it's one of the ones that have a very impressive profile because what they've done is they've created an augmented reality solution for. You could go look at this, yeah, for the use case of preserving wildlife and like they could actually, I mean, it's quite good what they've been able to do. So you can go have a look at what they've done. But they are like gaming communities also there. So if you guys, for instance, want to become a part of a growing gaming community in Kenya, like I could facilitate introductions to people you could talk to. Obviously it's in the infancy right now. It's not that we have a sophisticated ecosystem, but it's growing. It's growing and it's becoming more popular by the day. So yeah. Let me just check the one question. Yeah.
So sorry. So I have another question that I think probably it's not, it's quite tricky for me. The question is, can I have a hack around having a great machine to do game development, like something like gaming in the cloud or something like that?
Yeah, so there are gaming laptops. but to be honest, they're very expensive machines. If for instance, if you want to develop an intensive 3D game, I could recommend you go for a gaming laptop. You know, but that is if you're going to develop extremely 3D intensive, like graphics intensive, 3D intensive games that like the likes of Fortnite and all that, then maybe you might need to own a gaming laptop or a gaming machine as your development station for best results, you know. But if you're going to be a simple developer doing simple games, not highly complicated, not very intensive, you don't need all that, you know. So
Thanks so much for answering that question. Because in my opinion, I was thinking like having the hardware might be like a barrier to entry for people getting into game development.
No. It's totally dependent on your use case, to be honest. You know, so if you're going to develop games like Taken 5, Taken 7, then maybe you might need some very good machine, you know. But if you're going to be developing simple games and all that, or like simple 3D graphic games that are not very intensive on graphics and all that, then I mean, the available options in the market are quite okay for you to do anything that you want. So I would say for 80 to 90% of the use cases, because like a lot of AAA titles are companies that have a lot of funding to invest in heavy AAA title games, you know. For most of the use cases that you guys are going to have, you don't really need to invest much, to be honest. Especially if you do 2D, then it's not a big deal, you know. So
Great. Thanks so much for answering the queries I've had about game development. I think it's something worthy to consider. And
yeah.
I see that it's unfortunately time is up. So maybe you can have a parting shot, maybe so that you can inform us that whether we'll have a session next time based on what you shared, or how do we proceed from now?
Yeah, so personally, I guess on my side, I had anticipated it might take 2 sessions, maybe because there might be a lot of questions that might come up in this discussion. Basically, I think we've covered everything, unless there's a need for me to come back, which is you have specific questions you want to answer, or stuff like that. But in any case, I guess what I could say is there's a plethora of tools that have come up nowadays, and fortunately for us, in the past few decades, within the past decade, there's also been a surge of specialized game engines, which was not the case before. Like in the past, a lot of what people used to do is they used to work with games from scratch. So like without engines, or they develop their own engines and develop games on top of it. So it used to be a very tough science. So, but what has happened recently is, with the advent of game engines, they have solved a lot of problems, and there's a lot of focus on open source gaming, game engines right now. Like it's something that has become a lot more popular nowadays, is open source game engines. It never used to be also a trend, but we've seen engines that were proprietary being turned into open source overnight, you know. So it's an amazing time to sort of delve into this field, because of the amount of technology that is out there, you know, and what is now capable, you know, what you're capable of doing even on mobile, what you're capable of doing on our laptops and all that. So it's quite an interesting time, to be honest. And as also a parting shot for myself, I have actually tinkered around with game engines at the very C++ core. In fact, I've tinkered around with Love2D on the C++ core side and actually created Lua bindings for that. So it's quite fascinated with that. I guess we're good to close.